Welcome back everyone. Today we learn about work, energy and power. Imagine sweeping the floor. When sweeping the floor, we need to put in work to drag the broom onto the floor. But what do we mean by putting in work? Work is done when a force produces a motion of an object through a distance in the direction of the force applied. The SI unit for work is joules or Newton meters. To do work, we need to satisfy three conditions. There must be a force acting on an object. The object must move. And the distance moved is in the direction of the force. The formula for work done is the force multiplied by the distance in direction of the force. Here we have an object traveling. However, it is not traveling in the direction of the force exerted. To do this, we have to find the distance covered parallel to the force, which is the red arrow shown. Using trigonometry, we can say that the work done by the object is Fd cosine theta. So, what is energy? Energy is the capacity to do work. It also has an SI unit of joules or Newton meters. Lastly, we have power. It is defined as the rate of doing work. It has an SI unit of the watt. We can summarize its definition with the following equation. In conclusion, we can say that 1 watt is defined as the power required to obtain 1 joule of work done per second. Another equation to calculate power is as shown. We have already learned that power is equal to the force multiplied by its distance. We can substitute distance over time as speed. This gives us another equation: power is equivalent to force multiplied by the speed. Lastly, we have another version of power which involves electricity. We can use power as equal to current multiplied by voltage for electrical appliances like kettles and fans. This will be touched when we move to electricity topics. Let us talk about kinetic energy. Kinetic energy is the energy possessed by a body due to its motion. It can be found in translational, rotational, and vibrational motion. Take a look at the two vehicles. The car has a smaller mass, and it moves slower than the truck, whereas the truck has a larger mass, and at a faster speed than the car. We can use the following equation, Ke equals half mv squared, to find kinetic energy. This suggests that the truck has more kinetic energy than the car. Now, let us talk about gravitational potential energy. Gravitational potential energy refers to the energy possessed by a body due to its change in height. We can use the formula, mgh, to find the potential energy. Gravitational potential energy is measured relative to the ground. Thus, h refers to the relative difference in physical height from the ground. The work energy theorem is useful for many problems. It suggests that the work done on a body will be equivalent to the change in energy of a body. Hence, work done equals the energy change. Let us take gravitational potential energy as an example. Using the formula for work done, we can convert the force into the weight of the object. This gives us the formula mgh. Hence, by the work energy theorem, the change in gravitational potential energy is the work done on a body when it falls from a height. Now, let us use kinetic energy. Recall Newton's second law of motion? F equals ma. Hence, we will use this formula. This further gives us half mv squared. Now, here is a deeper derivation of how the work done can give us the formula for the change in kinetic energy. An object of mass 200 grams is moving at a velocity of 3 meters per second. Calculate the kinetic energy of the object. Do you recall the formula of kinetic energy? It is half mv squared. By substitution, this should give us 0.90 joules. A man picks up a box, 2 kilograms, to a height of 40 centimeters. What is the gravitational potential energy gained by the box? We can use the formula mgh. By substitution, we should be able to get 8.0 joules. Now, let us cover the conservation of energy, which states that in a closed system, energy cannot be created or destroyed, but only changes from one form to another. This means that the total energy in the closed system remains conserved. Here is an example of the energy transformation in a pendulum. When it transitions from A to B, the gravitational potential energy of the pendulum is converted to kinetic energy. Hence, the gravitational potential energy falls, while the kinetic energy rises. As it goes to point C, the kinetic energy is then converted to gravitational potential energy. Hence, it reaches the highest point at C. Take note that in this scenario, there is no loss in energy to the surroundings. Hence, the quantities of kinetic energy and potential energy in B and C may be lower due to losses in energy as heat or sound. In another scenario, we have a ball bouncing. As it is moving from A to B, kinetic energy is converted to gravitational energy, which is fully converted as we approach C. From C to D, the gravitational energy is then converted to kinetic energy as it is at its lowest and fastest point in time. In most scenarios, energy is lost to the surroundings as heat and sound. Take a look at the ball bouncing. As the ball bounces, the ball loses more and more of its total energy. This is because the potential energy of the ball is wasted as heat and sound and lost to the surroundings. Next, let us talk about efficiency. Efficiency is the ratio of energy output to energy input. It is presented as a percentage, and we can use the following formula as shown. We can also calculate the energy wasted as well. Take a look at the two light bulbs. Both are emitting 1000 joules of energy. But look, the energy supplied into the ordinary light bulb is more than that of the low-energy light bulb. This causes the efficiency of the ordinary light bulb to be much lower than the low-energy light bulb. This is because more of its energy in the ordinary light bulb compared to the low-energy light bulb is converted and wasted to other forms of energy such as heat to the surroundings. Hence, an ordinary light bulb is less efficient than a low-energy light bulb. Lastly, we shall talk about the sources of energy. These sources of energy are used to convert energy to electrical energy for our appliances. Let us look at some of them. Let us look at chemical energy. It converts chemical energy from burning coal or natural gases into heat energy. Heat energy is used to heat the air or water, so that it can move to and turn the turbine, providing kinetic energy to the turbine. This kinetic energy is used to power up the generator and provide electrical energy. Chemical energy is most commonly used as it has high power output. However, this method is not recommended due to non-renewable fuels like coal and natural gases, and it harms the environment by producing carbon dioxide. Hence, we can try other sources such as hydroelectric energy, whereby it uses water from a dam or reservoir. When the water is released from a good height, it converts gravitational potential energy into kinetic energy as the flowing water turns the turbines. Despite it being beneficial for the environment and using a renewable source, they are expensive to build and may flood habitats due to unpredictable weather like rain. Next, we have nuclear energy. As seen in the diagram, it uses uranium fuel rods, which emit alpha particles. These reactions emit heat, which heats the water and turns them into steam, which can turn the turbine by converting its energy into kinetic energy. They produce high amounts of energy and do not generate greenhouse gases, but they are expensive to build and produce radioactive waste which is harmful to life. Next, we have solar energy. This uses a renewable source, sunlight, and converts light energy into electric energy. Here is another example of solar energy, which is used to heat water for uses such as showering. It is environmentally friendly. However, solar panels are expensive to produce and they can only work during the day when the sun is present. Next, geothermal energy. This converts heat energy from the ground into kinetic energy as steam and other hot gases, which can turn the turbine and convert kinetic energy to electrical energy in the generator. It is cost-effective if built in the right places, but may threaten the environment as it may give off harmful gases. Also, it does not produce a lot of electrical energy as well. Last but not least, we have wind energy, which uses wind turbines. It uses kinetic energy from the wind to turn the wind turbine. This further converts it to electrical energy from electrical generators. It uses a renewable source of energy, and it does not pose threats to the environment. However, it depends on the speed of the wind, making it ineffective due to unpredictable weather. They are also noisy, which can create a nuisance for people nearby. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye-bye.